chapter 10.6 deals with solving exponential equations. And so today we're going to learn how to use logarithm, or in this case natural logarithm, as an operation in solving an equation. So if I gave to you, and I don't need you guys to write this down, but if I gave you, say, 2x minus 1 equals 5, you guys wouldn't think twice on how to solve this. You would know that you're going to add 1 to both sides, and then you're going to get 2x equals 6, and you're going to get x equals 3 because you divided both sides by 2. Right? And so again, we used a bunch of different operations to get x by itself, and even something more simple than that. If I say x squared equals 4, you would know that to get x by itself, you need to square root both sides, so you get x equals plus or minus 2. Or if I said the square root of x equaled 7, you would know to square both sides, and x would equal 49. Well, these are all easy operations to deal with. And so we're using different operations to get x by itself. Well, today we're going to use logarithm, or in this case natural logarithm, as a means to get x by itself. So in the first example here, I'm going to say 6 to the x power equals 42. Now we've never dealt with an exponent or rather a variable inside the exponent. So what I'm going to do to bring this thing down, what I'm going to do is I'm going to take the natural log of both sides. So what I end up with is the natural log of 6 to the x equals the natural log of 42. Now, we can use properties of logarithms to bring this x down. So I get x times the natural log of 6 equals the natural log of 42. And now to get x by itself, remember, natural log of 6 is not a variable. It's a number. We just haven't figured it out yet in our calculator. So we end up with dividing the natural log of 6, because the natural log of 6 is a number. And so what I end up with is x equals the natural log of 42 over the natural log of 6. Now, some people are very tempted to say this is equal to the natural log of 7 because 42 divided by 6. That is not correct. What you need to do is you need to find both of these numbers individually by putting them into your calculator. So I'm going to go the natural log of 42 in my wonderful TI-83, and that is going to be 3.737, or 738 if I round up. And I'm going to divide that by the natural log of 6, which is 1.792. Now I'm going to take these two answers here and I'm going to divide them out. And that approximately equals, I'll use my approximation, 2.086. All right, so there is going to be a little bit of calculator work here. So let's just go and check this thing out and see if it works. If that means that if I raise 6 to the 2.086 power, I should end up with something that kind of resembles 42. But let's go and find this out here. 2.086. I got an error in my calculator. What happened? Oops. I got 41.997. That's pretty darn close, I think. All right, so that means that 2.086 really was the correct answer. Okay, it's a little bit of a process, but I know that you guys are going to get used to it. If I give you another example, 2 to the x equals 30. Again, we're going to take the natural log of both sides. Now, you can take the log base 10, the common logarithm, but I want you guys to get really, really used to taking natural logs, because natural logs appear more in calculus, and they're just much, much easier to work with, and for reasons I shouldn't go into in this video. So what I'm going to end up with is the natural log of 2 to the x equals the natural log of 30. Again, I'm going to back this x down. So I get x ln 2 equals ln 30. I'm going to divide by ln 2. Now, again, people tend to get a little bit confused. Remember, natural log of 2 is a number. We just haven't figured it out yet in our calculator. So x is equal to the natural log of 30 over natural log of 2. Now I've got to figure these out individually. So the natural log of 30 in a calculator is 3.401, and then the natural log of 2 is 0.693, and that's it. Okay, so if I take 3.401 divided by the answer, I should end up with approximately 4.906. Actually, 7. I'm going to round up. It was 6.6, so I'm going to round up a little bit. But don't take my word for it. Let's go ahead and just check it out. 2 to the 4.907 power is approximately 29.994. Okay? Let's do another one. In number 3, they have made the problem a lot more complicated, but the process is still the same. You just have to make sure you keep your things straight. So I'm going to take the ln of both sides, so I end up with ln of 8 to the 2x minus 5 equals ln of 5 to the x plus 1. I'm going to back this both down, so I end up with 2x minus 5 parentheses times the natural log of 8 equals x plus 1 times the natural log of 5. Now, I need to get all the x's to one side. Now, there's only one way to do this. You just gotta have to bear with me and see how this is done. Remember, the natural log of 8 is a number, so I'm going to go ahead and distribute that in, and I get 2x times the natural log of 8, which, remember, is a number. It's not a variable. Minus 5 times the natural log of 8. Again, being a number, it's just something we haven't simplified yet. I'm going to distribute the natural log of 5 in, so I get x times the natural log of 5 plus 1 times the natural log of 5 is just the natural log of 5. Okay, I've got to get all the x's to one side, so I'm going to subtract x ln 5 from both sides. In doing that, I'm also going to add 5 ln 8 to both sides. So those are going to go away, those are going to go away. I end up with 2x ln 8 minus x ln 5 equals 5 ln 8, that came from this side, plus ln 5. From here, I've got an x in both terms. I'm going to go and factor that x out, so I end up with 2 ln 8 minus ln 5 equals 5 ln 8 plus ln 5. I'm going to divide by the big thing. And now I have x equals all of this stuff here. Now, unfortunately, there's only one way to go about this. I have to figure out what each of these are individually. So I'm going to pause this and figure it out. So hold on. All right, after figuring all that stuff out, this is what I got. 5 times natural log of 8 is 10.397 plus 1.60, which is the natural log of 5. I put it down here again because I had another natural log of 5. And then 2 times the natural log of 8 is 4.159. Hopefully you guys beat me to that answer. Let's go ahead and figure the rest of this out. 10.397 plus 1.6 is equal to 11.997. And then 4.159 minus 1.6 is 2.559. Now I'm going to take 11.997 and divide it by my answer, and I should end up with, as my final answer, 4.688, about that. Now you're going to end up with a little bit of a rounding error depending on what type of calculator you have. In my first time, I got 4.70, so I'm actually quite a bit off, but it's manageable. All right. Here we go. 16 to the x minus 4 equals 3 to the 3 minus x. There's no way I can get these bases to be the same, so I have to go ahead and use my logarithms on both sides. So I'm going to get ln 16 to the x minus 4 equals ln of 3 to the 3 minus x. I'm going to back these two down, so I get x minus 4 in parentheses, natural log of 16 equals 3 minus x times the natural log of 3. Let's go and distribute this stuff in. This is x times the natural log of 16, which is a number, minus 4 times the natural log of 16 equals 3 times the natural log of 3 minus x times the natural log of 3. Now the last example, I realized I might have moved a little fast, so I'm going to go ahead and slow it down a little bit. I'm going to add x times the natural log of 3 to both sides. Oops. So I end up with x times the natural log of 16 plus x times the natural log of 3 minus 4 times the natural log of 16 equals 3 times the natural log of 3. Those are gone. So now I'm going to go ahead and add 4 times the natural log of 16 to both sides. And so what I end up with is, I'm going to move this over, x times the natural log of 16 plus x times the natural log of 3 equals 3 natural log of 3 plus 4 natural log of 16. Plus. Okay, from here, they both have an x in common. I'm going to factor that out. There is a natural log of 16 plus natural log of 3 equals 3 times natural log of 3. I can go and move the screen over a little bit. Plus 4 times natural log of 16. Now I'm going to divide by the big thing. That goes away. I end up with x equals 3 natural log of 3 plus 4 natural log of 16 over natural log of 16 plus natural log of 3. I'm going to go ahead and pause again so I can figure out what the answer is in the calculator. When all the computations were done, I got x is equal to approximately 3.716. Hopefully you beat me to that answer by pausing it as well. Let's move on. Last problem that I can give to you that would stump you a little bit would be a problem like number 4 here. If I said 4 to the n equals the square root of 5 to the n minus 2, what you should do is you can do a couple of things. You can take this to the 1/2 power or whatnot, which is what I did. It made it really, really hard. Or you can go ahead and just square both sides. So you end up with 4 to the 2n equals 5 to the n minus 2. And now we're back in the situation where we can take the natural log of both sides, where I have ln of 4 to the 2n equals ln of 5 to the n minus 2. Back these down, so I get 2n ln 4 equals n minus 2 times ln of 5. I only need to distribute one side, so I'm going to go n ln of 5 minus 2 ln of 5. Oops, missed an n there. I'm going to go and I'm going to go and subtract n ln 5 from both sides. So I end up with 2n ln of 4 minus n ln of 5 equals negative 2 ln of 5. Same story, I'm going to factor out an n, so I get 2 ln 4 minus ln 5 equals negative 2 ln 5. I'm going to divide by the big thing here. So I get n equals negative 2 ln 5 over 2 ln 4 minus ln 5. Let me pause real quick and figure out what the computations of that are. And it turns out that n is equal to approximately negative 2.767. All right, let's take a look at some change of base formula next. When given a problem and you can't seem to work it out, I don't know how else to describe it, but if you have, say, log base 8 of 77, what you have to do is you have to use change of base formula. And what that is it's always either the log or natural log of the answer over the log or natural log of the base. So in this case, log base 8 of 77 can either be log base 10 of 77 over log base 10 of 8, or the one that we prefer to use for reasons we're not going to get into right now, natural log of 77 over natural log of 8. And in this case, they're both going to give you the same approximation if you punch it into your calculator, which is going to be about 2.0889. All right, change of base formula is actually relatively simple. If I asked you for log base 6 of 82, well, I'm going to go and change bases. That's going to be natural log of 82 over natural log of 6, and that's approximately 2.459. Again, change of base should not be really grueling. Log base 2 of 100 should be equal to natural log of 100 over natural log of 2, which is approximately 6.644. And the last example I'll give to you guys will be log base 4 of 48, which is natural log of 48 over natural log of 4, which is approximately 2.792. All right, and there goes change of base formula. Okay, good luck with the assignment. We'll see you next time.